Good morning everyone. Myself Manor Anjaya Dudam. I am from Walchand Institute of Technology from Solapur. I am intern at Emertxe Information Technology. During my internship, I am developed IoT based home automation solution. Learning outcomes basic of C, basic of C++, embedded system and IoT mini project. Basic of C are data types, int, floating point, conditional constructors, single interaction, if and family, switch, and multi-interaction for while, do while, operators and precedence, logical, relational, assignment, bitwise operators, causal levers are constant and volatile. Arrays Arrays called multiple value in the same types. Pointers store memory address. String are character array string setting. Storage classes like auto, static, define variable scope and lifetime header files. They are organize function and Markov declaration. Basics of C++. C and C++ are similar, but C is a procedure-oriented programming and C++ is object-oriented programming. Concepts of ops. Building a block of C++. There are using class, objects of class, access of modifiers, pillars of ops, encapsulation, abstractions, inheritance and polymorphism, virtual function, static leakage, dynamic leakage, and runtime polymorphism. C++ features there are contain set of OG names and standard templates library, friend function, abstract class, templates, type of function templates and class templates, exception handling. The exception is problem that arise during execution of programming work or three keywords dry, catch and throw. Embedded system definition combination of hardware and software which is intended to do a specific task. Example washing machine, TV, smartwatches, etc. Categories of embedded system. First one stand alone, follow instructions blindly, taken decision on its own without human intervention. Example self-driving cars. Real time complete complete task within a given deadline. If deadline missed, hard real time slot real time and film real time networked help getting connected. Example router and Wi-Fi. Mobiles. Yes, that movable designed for smart vehicles, smartphones. Components of embedded systems. First one microcontrollers, microprocessors, SoC. Second memory like ROM, Third one, sensors, analog and digitals. Fourth one, actuators. His worked like convert electrical energy to mechanical energy. Fifth one, human interfaces, switches, input and screen output. Diagnostic part, monitor, embedded systems and etc. Basic of program. Some basic programs to trigger LED, to print yellow on the first line of the LCD, to read value from temperature sensor and display on it LED, to test analog write function, to control brightness of LED with LDR, to control the inlet valve and outlet valve. Software used on this internship: Arduino board for writing code on the project, Pixin lab simulator used to execute the code. Third one, Blink IoT app. It can control hardware remotely. It can display sensor data. It can store data. Visual it. My first project of this internship, temperature control system. A temperature control system is automatically monitor and object a temperature of environmental or device to maintain the within a desired range. It is a widely used in HVAC, industrial automation, agriculture, and smart homes. Read temperature from LM35 and display on CLCD. These are the second is a cooler control system. A cooler control system is automatically regulated temperature by activity. Cooling devices like fans, pumps, and air coolers. When an environmental get too hot, it's used to homes, greenhouses, and service rooms. It maintain comfort and prevent overheating. To detect the change of the logic level, if the button which is a logic high, turn on the cooler. If button which is a logic low, turn off the cooler. This is a cooler control system like this. Third one is a garden light control system. A garden light control system is a automated outdoor lighting based on a condition, time, and user input. It is enhance energy efficiency and safety. Read the LDR sensor and vary brightness of lead accordingly, which is a controlling garden light based on the availability of sunlight. This is a setup of the garden light control system. Fourth one is a heater control system. It is a automatically regulated temperature by activating heating device. When an environmental get to hold, it is a ensure comfort and safety, energy efficiency in homes and labs. Detect the change of the logic level if the button we get is act logic high. Turn on the heater. If the button widget is a logic low, turn off the heater. This is a sample of the heater control system. Fifth one is the threshold temperature control system. A threshold temperature control system is designed to monitor temperature and trigger action when it is crosses predefined limit. It is widely used in smart homes, greenhouse, industrial automation, and public infrastructures. If the turn of the heater, if the temperature exceeds 35. Volume of water. Display the volume of water in a tank on CLCD. Inlet valve control. If the button we get the logic eye and turn on the inlet valve, and if the logic is low, turn off the inlet valve by sending command through serial communication. Outlet valve control. It is the same like a inlet valve, a similar process. Control the volume of the water in the tank. If the volume of water in a tank is less than 200 liter, turn on the inlet valve and send notification further. This is my all project. This is the conclusion of the project.
The fan is on. As soon as we decrease the LM35 reading, the LED get on and temperature increases. As we turn on the LM35 reading, the temperature decreases and becomes normal. Here the temperature again decreases and again gets normal. Fan is rotating. We can turn off the fan and we can turn on the fan. Here we can see that heater is on, and here when I turn off you can see that heater is off. And yes, this is my mobile screen. We can see that the tank is getting filled by water. It is connected to COM port 4. This is the Arduino Uno board. This is the main code I have written. The tank is getting drained out. This is my personal project named parking intimator. This is my code I have written. And here actually I am going to firstly compile, export compiled binary. It is done compiled. We shall save it. We shall open Pixim lab. We shall open file. We shall load hex file. It is 12. Okay. Uh, Here we can see that remaining 4 cars are there. Past 0 cars means 0 cars have passed and 4 slots are there for parking. As one car enters, the barricade will get open. As the car passes through the next ultrasonic sensor, the barricade will get closed. And we can see that the count is decreased from 4 to 1. As soon as the car passes through barricade 1, the barricade 1 will again get open. When the car passes through second IR's ultrasonic sensor, the barricade will get closed and the count goes on decreasing. Thank you.